Super. So hello everybody. This is very nice to have this short meeting here. We have two VESPA sessions today during the ERIM workshop. And what we are trying to do is to have first a presentation dedicated to users of VESPA this morning, and a second one more aimed at potential data providers this afternoon. So I'll try to make this introduction short. VESPA is one of the work packages of the Europlanet program currently. It actually started earlier. There are many teams involved, like 18 contributing participants. I'm not showing the details, but this is run by really a consortium of teams inside Europlanet. And this also includes contribution from the community. I don't know if people can see my pointer, I guess yes.
And also there's a link on the UVA thread and the chat to have access to the slides.
Yeah, and I've also put a poster somewhere on UVA yesterday, so it should be visible, and it will give you a more global presentation of the system. So, okay, VESPA is about two things, really. The first thing we wanted to develop initially was an interface for science users looking for data in the solar system fields in general, in a broad sense, not only planetary science, but also heliophysics and even exoplanets. And what we wanted to address is a very common problem, which is, okay, you're starting your work, a study in some field about one science question, and you're looking for data and you don't know where to find them, and you're not even aware of the available data, the public data available somewhere. So ideally, what you would like to have is a sort of query system with a unique entry point, which helps you write a query in terms that make sense for you, meaning that you want to write it in terms of scientific, observational, or instrumental parameters. And this query has to be sent to many databases, and you don't want to know where they are because you do not necessarily have the information, but you want it to be passed to Space Agency archives, but also telescopic archives, or even data published by a research institute directly, typically after a presentation. So you want to be able to make your selection of relevant parameters, like a given observational condition. You want to be able to grab the data online, to visualize them, to perform some level of analysis with common tools, and eventually you also need the possibility to pass selected data to specialized environments such as geographic information system if you're studying surface, atmospheric tools for other purposes, and so on. The second aspect, if you're a data provider and you do not have to be a space agency or an observatory to be a data provider, you can be the same scientific user after their paper is published, who wants to share their data because they have derived a small data set which is useful for the community, and they want to make it public and findable. So when you're in this position, of course, you will need a very light system in which you would share your data where it can be visible and reused by other science teams. So this is a mixture of what is called fair access to the data and following open science policy. Okay, so we are doing this in 4 steps in VESPA. First of all, we identified very early that we did not want to redevelop something new. Instead, we stick to an infrastructure which already existed, which is a virtual observatory developed in astronomy for exactly the same purpose, but for fixed object in the celestial coordinate frame. So VESPA is different because this is solar system data, and we had to add to the virtual observatory what was missing to support solar system data. So the first element is vocabulary large enough to describe physical and observational parameters used in this context. And this has to address not only planetary surfaces, atmospheres, small bodies, but also magnetospheres and also heliophysics. The second element is that we needed a generic interface to write queries and issue queries to the connected data services. So this generic interface is called the VESPA Portal, and Nicolas Manot in the next talk will give more detail about this, but this is only one access mode to the data content, which is more like a discovery tool when you don't know anything about what you're looking for. The third point is maybe the central one, which is providing data content in this system, so, which means that the data have to be described with the finest level of detail possible. So we have currently several data services, a number of them, in fact, including the largest one, which is the ESA Planetary Science Archive, which was an early contributor to VESPA. And this includes data infrastructure which predated Europlanet and VESPA, in particular SHADE, which will be presented by Bernard later in this session, but also PIVOL, which will be presented in the amateur professional session, I think. AMDA for magnetosphere and plasma, MASER for radio observations, and so on. And the fourth point is to also connect to visualization and analyzing tools. So we are not redeveloping new things because that was simply impossible in this kind of time frame. But instead, we've been connecting tools from the astronomy field, and we've been asking their developers to add functions which are specific and important for planetary science. But we're also connecting to geographic information system and these kind of things. So this is important. And what is important in this system is that there is no data centers, not a single data center at least. The data are located in the institutes which distribute their data. The VESPA team is supporting the data providers, and users just can access the data without any kind of limitation and no registration. So I will pass very quickly on this one. This is the same information in a graphical form. Again, the important part is that people are providing their data with a website or not, but they're all registered in a central place, which is the Virtual Observatory Registry, and all these services can be queried with a protocol which is called EPN-TAP, which describe the condition of observation. Then we have the portal, we have plotting tools and alternative access modes to the system. So Chloe will make a demonstration, a list of examples. So this is one of these, but I just put this information for further references. Chloe will discuss it in more detail. What is important to realize is that each data service is actually a table describing data elements, and there are usually files, but not necessarily files, but this is the most standard situation. And these files are described by a lot of parameters, which are all standardized, uniform, and therefore all these tables have the same columns and the same kind of description, so that they will all respond to the same queries in terms of database access. We have alternative accesses, in particular with Jupyter notebooks. That will be an advanced situation that Pierre will describe this afternoon. And I've put here the current list of open data services. The open ones are in black, and plain case. So as you see, we are paving a lot of different fields in solar system study, atmosphere, surface, small bodies, and so on. Okay, if you need more info, I've put here the important links for further reference. And I will close this presentation by just showing pretty images. Again, this is only for reference. I'm not discussing this. I want to go as fast as possible this morning. But we have tools for images, which are very powerful. You can superpose different things. We are using multi-resolution maps, which are extremely handy to superimpose information. TopCat is a tool for tabular data, which has extremely powerful visualization modes, including in difficult situations like this one that you may recognize. You can include the data inside the table describing the data, which is an advanced usage, but we will discuss this morning. We have several systems to describe footprints, either with contours or with what is called mock, which is a nil-pix tessellation on the sphere, which is extremely robust and efficient. We have CASIS, which is a tool for spectral data. We have a connection with Geographic Information System, at least QGIS, for which we wrote a plugin. We also have tools for time series coming from another community, and we've been developing also a way to identify, to describe and locate features in dynamical spectra, in particular for radio observations. We have tools to follow planning of operation for a space instrument, and we're also connecting other tools, in particular in this instance, ImageG, to provide image processing functions to the virtual observatory. I will stop here for this morning. I've just added this for further reference if you're interested. So thank you for your attention. And the next presentation is
Nicolas.
I will start with supporting slides. It's going to be a very short demo. By the way, my name is Nicolas Manot. I am part of the VESPA team, and I'm responsible for improving the user interface and the user experience for VESPA. So this is going to be very an introductory demo, giving you an overview of the interface. So as Stefan mentioned, VESPA is an integrated system connecting many data services related to planetary science and solar physics. And what you see on the right side, maybe I can remove that here so that you can see this schematic diagram that illustrates the main functions and flows of the VESPA portal. So at any time, if the connection drops, please let me know. Otherwise, I will just speak to myself. So don't hesitate. So as Stefan mentioned, the VESPA portal lets you query all these services simultaneously using science-oriented search parameters. It's a very important part of it. To discover and identify data services of interest. So you can identify data products of interest by refining your query that fits into the VESPA portal, and then you can download data of interest that you've selected with the portal, or you can send them to VO tools. And this is an important aspect of it, because there are many things that you cannot do within the VESPA portal that will be available from VO tools or your own analysis tool. Moving on to the next slides, I told you that search parameters are a very important part of the VESPA system, because they are all standardized. And here you have a reference to the EPN tab search parameters. And here you have an illustration of all these parameters that are grouped by theme or topics. So you have main parameters where you can select the targets, instruments, or processing level. Then you have everything related to timing, location, spectral aspects, illumination, and data reference. my last slides before jumping into the demo is about data and metadata, because I know that this can be confusing sometimes. So on the left-hand side, you can see this diagram which illustrates, what's returned from a query when you query a single EPN tapped data service, and the results is in the form of a VO table. And so also here you have a reference to this VO table, which is in XML format. And whenever you're going to download the data products metadata written from your query, they will be in a VO table format. So this table can be of two types, although the main type is going to be metadata. You can have some results in form of data. So this is what you see on the left-hand side here. A data table holds the data itself. It is the data. And for example, you will see that there is a service called the main characteristic of the solar system planets, and in which you will have everything within that table, and that constitutes the data. In most cases, you will have the metadata table, which holds the list of the data product that is matching your query. And each row, what we call a granule, correspond to a data product. And you have columns which provide information about the data products. Those are the metadata. And one particular information that is really important is the access URL, which gives you the link to the data. So now, jumping into the demo, and with this first slide, I just wanted to illustrate the overall flow that you can go through as a user and the interface. So essentially, you're presented when you land on the VESPA portal with, on the left-hand side, all the search parameters. And on the right side, you have all the data services that are currently connected to VESPA, for which you have a results. And green means that you have results. Red, there is an error. Gray means you have no results to your query. At any time, you can click on each of these data service for which you can see the results. At the moment, there is no query being done. So you can see that, for example, for this data service, you have over 6,000 results. And you can jump right into this data service results, which will take you here, or you can refine your query. So let me now jump into the interface itself. So vespa.opspm.fr will take you to the interface. So this is the same interface that I just described. And we're going to make a very simple query where I'm going to be looking for Mars hyperspectral data. So I will type in Mars, and I will be suggested some targets. And you see that it auto selects the target class. And then I will click on data products here because I want to have spectral cues. And I just hit enter, or I go down and click submit. And so now you see that the spinning wheel for each of these services will be going on. And as soon as there will be results for each of these services, they will be presented to you. So you see that among all these data services available, you have here 4 for which you have results. And we're going to pick Omega cubes, for which we have more than 7,000 results. And this is the other view of the interface, which presents to you the results of your query for a given service. So as it was shown by Stefan earlier, you can see, okay, first you can see a bit more description about the data service itself, and you have a link to the data service that is published by the provider, where you will find more information. And we always recommend you to go to that link to learn more about the data and how to manipulate the data. So here you see the table with each of the columns. Here you only see 6 columns, and you have here some toggles that lets you select the different columns. This will help you identify which products that might be suitable to your research. And at the bottom, you will see each row here is selectable. And once you've selected some data products, you can either download the data, or you can download the metadata downloading the metadata, meaning that you're gonna get a table which contains each of the selected rows with all the metadata that you will be able to visualize in the VO tools or with your own tools, which could be also Python based. So what I'm gonna do now is I'm just gonna refine my query because I want I'm interested by data over Olympus months on Mars. So I'm gonna click on location and I'm gonna select the special frame type, which here in this case will be body frame because I'm gonna be providing longitude, latitude. The data range intersects the range defined by center and width values. So I'm gonna select the longitude, which is for Olympus months 226.8 degrees with a delta of 1 degree and longitude 18.3 and latitude delta is also 1 degree. So I'm hitting enter and now you can see at the bottom of the table that we have 52 entries, 52 results for this. And now what happens if I go back to my services results? So really the huge advantage of this of VESPA is that you can see that this query, which is now more complex because you can see that now I've been querying also about positions. And you can see that also it gives you the results of the data services for which your query match. So now you can see that you could do like cross analysis of Omega data cubes with Planet Server Crescent data. I'm not going to go into the details of that, but you can see that you have matching results for two of these services. Going back quickly to the results for Omega, I've shown you already how you can download your data. So if I select two data and I click download, earlier I got some error, so hopefully now it's going to be working. But as soon as you do a download, it's going to be downloading higher volume of data. If you want to dig a little bit more into identifying the data products, you would rather do a download of the metadata, which, by the way, and I'm gonna leave it here for the demo, is something that you can immediately do from here. So if you click here, download, you will download the VO table. So if you want to download your search results, you download the VO table. And if you want to download the data itself, you do as I just shown, you select your different rows and you click download and you will get a zip file in which you will have the data. Then the next step is really making use of this data. And this is why we recommend you to go to the data provider website, which describes the service in more detail and how we can use this. So I'm just gonna finish by one last slide because I was mentioning earlier that I was responsible for improving the UI and UX for the VESPA portal. And so there is an ongoing redesign work and would really appreciate your feedback. So we have set up a very short survey. I'm gonna copy and paste the link to that survey in the chat. And so if you can go there, we would really appreciate your feedback after you've been using VESPA during today or this week. So that's all for me. Thank you for your attention. And I hope you could hear me and you could see everything okay.
Yes.
Okay, good.
You hear me?
Yes, I can hear you.
Thank you.
And by the way, if you have any questions and also along the workshop today, feel free to use the Q&A of the Wova tool. So in addition to your feedback to the survey, any question that you have would be also valuable for us. So don't hesitate.
So I will follow on with some examples of some other examples of queries in VESPA Portal. So here's the link to the portal, and if you have access to the comprehensive web page, you have access to our different slides if you need to have the links and so on. So the query parameters we have on the left correspond to the EPENTA parameters, which are defined in the IVOA documentation. But the main parameters we are interested on, and basically the target names which will define on what, for example, Mars, Sun, and so on. We may be interested in the target class, if you want comet, planet, or satellite. We can also search for a certain type of product that is the EPENTA parameter data product type. And if we define the spatial frame type, it's not the main parameter, but it will define the C1 and C2 parameters. And for example, if we are in a body spatial frame type, it will mean that C1 is the longitude and C2 is the latitude. And you have the different spatial frame type and the corresponding meaning of C1, C2, and C3 on the documentation that I encourage you to have a look at. So we have VO tools that enable us to plot and treat our resources from VESPA. It's linked with what we call SAMP interface, which allows to exchange data between locally opened applications. So with VESPA, and for example, we have the two main tools we use the most often that are TopCat, where you have some example on what we can do, and you've seen on Stefan's presentations too. So you can install it following this link, but if you are on the Debian, it's very simple because you can use apt-get. And you have also Aladdin Sky Viewer, where you can plot features on the planet surfaces. And to do that, you will need to have the planet option. And we also use the beta version of Aladdin because there's some features that are not yet on the last release version. So you have the command to run Aladdin like we want it to be used for our services. So the first example is a mass illumination selection. So depending on the angles of the illumination source, the images can be really different depending on the shadows. If we want, for example, to have a map of Mars and choose the illumination angle, the phase and the incidence, we first have to type Mars as target name. It will automatically put that it's a planet, and for example, in this case, we will put the phase and the incidence angles that you see correspond here from 0 to 60. And then we search here on all services of the VESPA portal and not on only one. So here we see that we have two services responding, and we have the number of granules that are responding to these parameters. Here we will go, for example, see the CRISM service. Sorry. and you'll see there's spectral cubes, and we have, when it's available, thumbnails that are quick previews when you pass the mouse on, and we see the different images with this type of illuminations. Another example will be to find Mars atmospheric profiles. So I will go back to VESPA main page. And here, what I will see is we want Mars, and we want profiles. So I will see every services giving me Mars profiles. Maybe the connection is a bit slow. And we see free services responding. That is not normal. Okay, some are a bit slow. And here I want you to have a look at SPCAM service, which gives Mars Express atmospheric profiles on Mars of temperature, CO2 density, and ozone density. And I will show you, for example, how to go plot profiles on the tool TopCat. So here I select SPCAM measurement and the corresponding MCD simulation. That's how the service is built on itself. And I will send the data. And here the data is VO table. So it's understandable by TopCat. So data selection and send table. So it will send it via SAMP. And then I click yes, and I have my two granules here and the data corresponding to the granules I selected. So if I want to plot it, I will just select the plot and select the axis. And here I have the temperature here and the altitude above Mars 0 datum, so the altitude. We can, for example, add a line, add a label. And so we can also add a new other thing for another service. And here the MCD profile that we will plot on the same graph.
The MCD profile in blue is a simulation from the Mars climate database.
Here. Yes. Okay, so another thing I wanted to show you on this service is the data link. So data link is a feature provided by the VO that allows us to add for each value either a list of links or a formula to link to related information. For example, here what is implemented is other simulations of Mars climate database, but on other scenarios, but on the same coordinate, time, and so on. Okay. Last example here is the Virtus VEX coverage. We have an EPN-TAP parameter that's called coverage, and it's a mock. So it it's defined. It defines the a zone, location, and for example, here I want to select. I will select the service Virtisvex. And for example, here I want only profiles taken in the morning between 5 and 9. And here it's not NIPI and TAP parameters. It's a parameter defined by the data provider. So we have over here to search for it. So I will say. No, it's just not on the parameter we can search on natively. And I want, for example, the North Hemisphere only. So here, C2, and we have here cubes and spectral cubes, and the cubes are only geometrical information and not data. So I can select the data product type as spectral cube. And with these parameters, I have. Oh, I don't know. Oh, here. Okay, and then here I have to select the metadata because the coverage we want to plot is a metadata and not inside the file linked here. So I can send metadata here and open it on Aladdin. So Aladdin with the planet option, you have solar system hill peaks. So you can choose different maps, and hill peaks increases its definition when you zoom in. So here we are in Venus. I load any map on Venus, and here I have the data I sent from VESPA. And for example, I can I was not in beta, so that's why. Yes, it's a slow. No. I have a problem, I'm sorry. Okay, I will go back to the slide. I have it on the slide. So here is the plot if everything works normally. And you can easily plot the coverage of every data that have coverage implemented. Okay, I will leave the place to Stefan to show you some other examples. Okay.
Okay, thank you. I think on the planning we have a demonstration of SHADE, which will be given by Bernard. So, as I said previously, SHADE is one of the data infrastructure included in VESPA, but predating VESPA. So it is a bit specific. It has an EP and TAP interface, but SHADE is really a big database of many laboratory spectra, which are described, not only the data, but also the samples to a very large extent, which is much more detailed than what we have in EP and TAP. So the EP and TAP interface is very nice to query on the first order this kind of large database with very detailed information. It is very practical when you want to compare laboratory data with observational data. So you start from looking at observational spectra of a planetary surface, and you can look in shade or similar materials. But the level of description is much higher in shade than on its EP and TAP interface. And this is what Bernard represents.
Okay, I will present you a series of user cases, in fact, to show you what you can search and how to search them. Just to remember a little bit, so I will jump from a PPT and from the online. Just to remember that SHADE has two different products inside. First, it is a set of spectral database coming from various groups, more than 20 currently, that cover most of the solids for planetary science and astrophysics. This can be synthesized in the lab or up to extraterrestrial sample, and it covers mostly the UV visible and infrared. And you can find different type of product. And the second type of data that has been put online, started to be put online 1.5 years ago, is two bandless database, one on absorption and the other on Raman spectroscopy. It covers mostly simple ice and minerals. So let's start a first case. For example, you have a spectra of Triton or Pluto or any large KBO, and you want to compare the position of the band of methane with that of pure methane or methane in nitrogen ice, because nitrogen is one of the major constituents frequently. So you need to check the band shift, but you want also to run models, and after you want to get the data for the radiative model. So you will want to search CH4, the optical constant of CH4 in the near infrared range. For this, you will need to search spectra. So on SHADE, you have the different type of search, spectra, band list, and band, also publication on solid spectroscopy. So let's put CH4, start to search spectra. So you get yes, you get a lot of spectra, but if you then you need to refine. You wanted to have what is mostly spectra of type optical constant and absorption coefficient, because you know how to use them. So you will restrict to this 29 spectra, but you want also to restrict to the near infrared. You go to instrument parameters. You can here in the spectral range type limit to the near infrared and search, and then you have just 4 remaining where you can find the one for pure CH4 and the one for CH4 in nitrogen. So then let's go back. You can have search. You can have a first look at the data just here, and then you can also have a look at them, at the detail, and download them, for example, using this. And you can set also the parameter. For example, you prefer to download them in nanometers, and you want to cover specific range, you can specify here on any other parameter. And when it is ready, you can send to download. It will be downloaded asynchronously, so you can continue to do your search. And let's go to another example. For example, now you are working on asteroid of C-type, and you want to see which meteorite has a similar spectrum. So you want to search carbonaceous chondrite, class C1 and CM, the ones that are closest to asteroid type C, and of type 1. And you want to search visible and near-infrared reflectance spectra to compare to your observation. So you go back to your search. You type meteorite, for example, just to see if there are spectra of meteorite inside shade. And then you see that there is 976 spectra. We have really a lot of them. But you want to refine. But for example, if you want to search spectra of the class of the group CO, you cannot search with a bar because CO will interfere with the CO molecule. But there is a special place with extraterrestrial object where you can refine in detail. For example, you want carbonaceous chondrite, then you define in the group. You want class 1 only, for example, and then you search, and you see that you have much less. If you have only less than 700 spectra of this type, it's already good. But no, the one was not taken into account. Okay. Wait, is it not? No, sorry. Sorry, I made a mistake. In the class, you want to select C1 and CM. I forgot. And it is in the petrologic type, so you want the type 1 only. And then you search. You get 33 spectra. And you want to restrict to reflectance spectra. So you go to spectrum, the type of spectra. You type, for example, reflectance. And you choose the different type of data with reflectance, for example, all this. And you got 23 spectra. And in fact, the last one are mostly irradiated, and you have something like 7 different spectra. And for example, you think the most interesting is Orgueil meteorite, and you can type it directly. And then you will get only the 3 spectra of Orgueil, for example. So, and you can go directly to the data where you have all the data with all your parameters. Another case, for example, you are working on Titan and you want to search where there are 13 carbon-13 isotope of nitrile, because you want to search them on define observation program on them. So in that case, you need to use a bandless search. And you go to the bandless search. You can type nitrile, for example. I have already in my list, memory list. You can search them. And you see you have 8 answers, but you are interested only in absorption, not in Raman. So in the bandless tip, you search, you define absorption. So you have only 5. And then you can go by hand, for example, check if there are, let me see, I will take the other. I will take, for example, the CH3CN and have a check inside. You see there is a lot of bands. It is difficult to see which one is 13 because you don't know. You can go and look at the spectrum in a dynamics plot. if it is plot, yes. And then here you can look at the contribution of the different isotopes. For example, this one has 2 bands in it, and the other isotope has 3 bands that is known. So you can go to this band and check them. You can also have a look at the band list itself by looking at the list of the band list, and for example on specie, or put in order the specie, and then you will get the 13 CO on the top, and then you can see all the different bands and have a look after at each time. Another example, for example, you are searching for an unknown band with a position on IO. You know it is on IO, but you don't know what it is. So in that case, you will have to search band. You go back to the top. If you want to go back, you search, you want to type a value. So the bar is not the best place to type a value. You have to look at a filter. And in one, here you have all the band. You have more than 1,000, so don't check by hand. And then you have a filter with a position. For example, you put 4705, more or less 10 wave number. It is more or less an uncertainty you have. And then you get a search, and you see, okay, you have 3 results. Some from CO2, some from SO2. But you know that you have also another band at 5045. So you go back to the filter. You have an option where you can put a second band, 5045. I don't remember. Yes, and you know it is more or less okay. Let's say 10. But unfortunately, as you see, CO2 has also the same. are also bound at this place. If you know that is in fact, okay, it is only 5 wave number because you are more accurate, you will see that it filters only to this SO2 band. But okay, you are not very sure, but you know that there is also a band at 3933. So let's change it to 3933 and to 10 wave number, and you get the same result. So your band was 3 new 1 plus new 3 combination band of 321602. So another example, more on Raman spectroscopy of minerals. You have, you know, a band very accurately, more or less 1 wave number, but you want to know, you know it is a carbonate, and you want to know which carbonate it is. In fact, what is the other band? So you go back to bands again. You search again for the position. You can take carbonate to filtrate about carbonate, but here you will define that you want Raman scattering only here, and then you put the position 84.5 more or less 1, and you search. But as you see, unfortunately, there are 5 different carbonates because when you look at the spectra, there is a lot that are very close. But you know that there is another band at 150, and then you can add a second filter, more or less 2, and you can get. Then you know that is in fact aragonite. You have 2 bands because in fact, if you check inside, you have 2 different crystallographic sites that contribute to the same bands and that are not shifted. So just as a last case that we cannot search currently, it is a current case that on which we are working. It is CO2 and Ganymede. And we know that it is not pure only, because if you look at the bands that are in dotted line, at the equator or the pole, on the pure CO2 in red, you see that it don't fit neither the position nor the width of the band. So it is necessary to compare with CO2 in a lot of different compounds, either diluted in other eyes or as compound with other, like CO2 clatrate, or absorb on other solid. So this here is just a review of about 20 different cases of CO2 in various things, and it is necessary to compile and review all these many different band lists, and then after put in the database, and then it will be possible to search them. Okay, thank you.
Thank you, Bernard. Start hands-on session now, but this is the right time if you have questions or comments or feedback to provide. We are also here to get feedback from the audience. Especially if you have your own use case and you want to try to implement it and something is missing, just let us know, because we can refine the interface. We can still work on the protocol. I will leave the floor to Chloe to introduce sports.
Yes, during this hands-on, we really want you to identify what service is interesting for you for your science. We want you to also into this service identify what project interests you. And you to try to download, to visualize, to use video tools, and you can ask us questions, and we can see this together. If you have the slide on the page, we have some suggestions for those who are not so much inspired on what they want to search. So we have some examples with we have an example with the answers, and we have several one with a different level of different difficulties. So yeah, let's try to do that.
Okay, so what we're suggesting here is that you start playing with the interface with the VESPA Portal, and try and see if you can actually provide a target name or your main parameter of interest, but that usually includes the target name. If you don't have a specific ID, we suggested we have some suggestion of small exercise to perform in real time. Some are easy, at least one of them is difficult, but we need to provide the URL of this page.
Yes. It's on the chat, and there's a thread on
Okay, so those are the suggestions we are providing now. If you don't have a clear idea of what to search, you can try and find this. The first one is very easy. For instance, this was recovering the original images from CRS, which was the first CRS images from HST, which was the basis of the first detection of surface features on CRS, which in format unfortunately proved to be entirely wrong, but still that was nice, and the paper was very impressive at the time. So if you want to get an idea of what are the data, the original data, you can try and and grab them from the VESPA portal. Of course, this is in the HST dataset.
And, yes, if you have some question on what we said, you can ask. And I don't know if there's somebody following online, but it's the same.
There are a few people.
Okay, online you can raise your hand if you have questions.
Yeah, of course, alternatively, you can try and play with the shade main interface, which again describes the samples and spectra in more detail than what you have in the VESPA portal. Although the data are the same, if you're more interested in samples and spectra in the laboratory, you may want to play with interface.
Yes, and if you have any question how to search some type of data, just ask. And, we are interested to have a feedback on user case also.
Yeah, so this is one of these funny sessions in which we actually expect the people to work. But if you have any question, interrogation, feedback whatsoever, we are glad to get it.
I will have a word on the Mars example. If you want to continue to have a look at the portal, go ahead, but I will just show you another example. So, this is a search on a service on Mars craters that gives information, the diameter, the position, and the depth, for example, of Mars craters. So if I want to have only craters that are higher than 100 kilometer diameter, I will go to the VESPA query interface. Okay, go to Mars craters service. I will zoom in. So the diameter is not like we wanted to to be. It's so it's not an EPEC standard parameter. So we have to search it on an additional parameters. So here it is. Okay, so now we will send it to Topcat and Aladdin because we want maybe to plot the shapes of the craters on a map of Mars, and we want maybe to make some. I will send table. Send the metadata because what I wanted to say is that in this table, for example, the table is the data. So the EPN table contains directly the data. It has no link file linked, and every row is a catalog item. So I will send it via SAMP. And I closed, so I will load Topcat and Aladdin. Okay, it asks me if I want this data to be charged. Still don't know the error. Last time it was just a bit slow, and it was okay finally. Okay, it's here. So here we want to load an ILPIX map on Mars, so solar system Mars, and we'll load, for example, this map. And yes, yeah, as I sent it before, I have to resend, or just I could have sent it from Topcat, but yes. And here we have the center of the craters. And here we have in the properties the possibility to show associated field of view. So our craters are now plotted in the planet. And yes, it's just one example of feature of Aladdin, but there's a lot more and more complicated one. But it's you can do a simple thing easily. Go back to Topcat. We can make a plot here. And here, for example, we want to plot the crater's depth depending on its diameter. So depth and diameter. So we have it. For example, we can put log here. I don't know if it makes sense, but we can put log axis. We can have 3D plots also. We have also the possibility to plot marks and so on. What I wanted to say that I forgot is also here. When you have picked the parameters you choose, you have made your query. You have here, you can click and have an ADQL query corresponding, and you can also complete it and make what you want on your ADQL query. ADQL is a SQL. It's specialized for Astro, but it's SQL basically. Here is not the best example because there's only this, but you can. Okay. Now for the wrap up. Yes, and now if you have comments, we want your feedback on the portal, what you think about it, what you expect from it. If you, I can give you the mic, see if someone has something to say.
Yes, so I have just one question about the ADQL, the Astronomical Data Query Language, because I guess that there are some specific terms for planetary science that have been developed over this project. Is there a dictionary of those terms that we can look so that we can make those queries more
Yes, in IVUA document. And yes, you have the latest, and it's defined here. Yes. I think that's the good documents. Yes. I can put the link on the chat.
Okay, to complement this answer, ADQL is extremely close to SQL. The main difference are related to a spherical geometry, which was not existing in SQL at the time where they defined that. But I wonder if your question is not about the EP and tab parameters, really.
No, it was about this because sometimes I don't know if I have to look at the general information in the IVOA or if it is in some place in Europlanet or VESPA, but I see that it's in the main one, so it's good to have it there. Thank you.
Yeah, if there are other questions, we are happy to answer or get comments if you see anything, any possible improvement on the interface to make the system more flexible or more friendly for new users, because this is an important thing we want to improve if possible. So we are reaching the end of this session anyway, so.
Sorry. I wanted just to remind you to talk about this afternoon, what's the program. So this afternoon, Pierre Le Citadin will talk about using Jupyter Notebook and use basically Python to query the different EP and tab services. And we will talk also about the data provider side, the way to share your data on EP and tab.
And we try to make this as easy as possible, which was not easy for us, but hopefully that should be something less demanding now for research teams. You don't have to be a space agency to make your data available, and this is extremely important for us. So I think we will close this session now, and we'll reconvene. And we'll reconvene at 2 after the break.
Thank you. I wanted to ask, a lot has been said how to get data from providers to users, but actually many of the providers can also be users. So can it be shared over VESPA, basically in between some like providers, databases to complement their data of course, while respecting all the ethical problems that may arise.
I'm not sure what you're referring to. You mean data providers who want to complement their own database by adding data from external?
Yes,
yeah.
That's what I mean.
Yeah. Okay, it depends on the situation. The system is very flexible anyway, but if I understand correctly, this is a gray area where you have to take care of political decisions and situations. So if you have a project to concentrate data from several institutes around a project, a space instrument, for instance, let's say that you are the PI and you want to get all the derived data products from your team, which is a fairly basic situation. Yes, I think the best way in this case or similar cases would be that the PI is actually in charge for his whole team, even if there are several institutes. So there will be a single data service concentrating the results from this instrument, this experiment, describing them, and providing them from only one server. This is what would make sense to me. If you have a very complicated instrument and teams working in very different areas, let's say imaging spectroscopy of Mars, but people are working on the surface, others on the atmosphere. You could imagine to split this in two. Again, this is a matter of internal organization and efficiency. As long as there is one PI to an instrument, it makes sense to have a single service. Yes, probably. But this can be difficult to do because the idea of this distributed data system is to leave the data close to the expertise on the data. And to me, this is very important in the long run because it means that if you're in charge of your own data, the one from your own publication, it will be much easier for you to make adjustments, updates, complements to a data set. If you have it at hand, this is easy in your own institute. If you have to ask a succession of relays and agencies or whatever, it will be more difficult, of course. And I think the whole thing of the virtual observatory is here. Even if you're a small team, if you can be in charge directly of your data, including the distribution part, because all you need is internet, in fact, and a server which is always on and accessible. The rest is relatively light to operate, and once it is installed, you don't need an IT service to make it run. So this level of organization you are referring to me, something political, and this is part of the design of a data service. Yes.
Thank you.
You have another question here?
Hi. It's a question about, well, VESPA. You show if you put the name of the target, you could obtain the features, but you could, in this platform, to access to a space of the sky, for example, with a coordinates, you could obtain a surface or area of the sky too,
Yeah.
or only you have to know the target, the name of the target.
Oh, well, it depends. You're referring to telescopic images, right?
Yeah, exactly.
Okay, so for telescopic images, you would expect people distributing the data, and this is the case of the Parsec service, for instance, for the telescopic network. We expect the data provider to identify the main target in the table. So if you have an image of Mars on the sky, you want the data provider to say this is an image of Mars. The problem with moving targets is that they are moving, of course.
Yeah.
So if you want to get it by this right ascension and declination coordinates, you also need to provide the time, but you also need to know the ephemeris, and it's becoming a completely different matter. So some people are doing this, but this is not the way we are doing it on VESPA. We're asking the providers to identify the main target if this is feasible. And so for the user, you will typically search for Mars and possibly indicate that you want a celestial frame if you're looking for telescopic images. And it will just tell you that the images the coordinates will be provided as right ascension and declination, but you don't have to provide a value.
So to research new objects, so it's complicated. So with this,
yeah, there are methods for this, but this is to me this is a bit more than looking for data. What you're referring to is really analyzing the data content and saying, okay, I have a frame on the sky. I know the time. I know the bounding box. And I'm looking for object present at this moment in this bounding box. There are tools to do this. One of them is called Skybot. and is provided by another institute at the Observatory of Paris. It is included in Aladdin, by the way, so you can do this work in Aladdin. Well, yes, this can be very powerful. ESA is doing this on their archive, but this is really a way to analyze images. And what we would expect in VESPA is to make the result of this analysis available as a table.
Okay, thank you.
Yeah, other questions and comments? I'm afraid we are getting late now, so we probably need to close here. And we will reconvene at 2 for more use cases, more elaborated advanced usage, and also some discussion for potential data providers. Thank you very much for attending.